In this video, we're going to find the equation of the tangent line to the function x e to the negative xy equals y squared at the point 0.571433, 1. So this is going to require some implicit differentiation, and we've got to be careful, make sure we follow all the rules that we need. So first off, let's talk about the left-hand side. Notice I've got a product. Within that product, I'm going to have a chain rule, and within that chain rule, I'm going to have another product. But the overall structure of that left-hand side is a product rule. So let's start writing out the derivative of the left-hand side. So it's going to be x, I'm going to hold constant, times the derivative with respect to x of e to the negative xy, plus e to the negative xy times the derivative with respect to x of x. Over on the right-hand side, we don't need any special rules. It's going to be 2y times y prime. Remember, the y prime is necessary because it's chain rule. We're thinking of y as an implicit function of x. And so in my notation, y prime is the derivative of f. Excuse me. Okay, we have more derivatives to take on this left-hand side, as you can see. This one's going to get a little bit larger. So I have x. Now the derivative here is going to be a chain rule. The derivative of an exponential always has itself in it. E to the negative xy times the derivative with respect to x of the inside function, which is negative xy. So we're going to have another step of derivative there. Over here we have e to the negative xy times the derivative of x, which is just 1. And this side again is done, 2y y prime. We have one more derivative to take before we start trying to solve for y prime. So we have x e to the negative xy, and now we're going to take the derivative of this with a product rule. So negative x times the derivative of y, which is y prime, plus y times the derivative of x, negative x, which is negative 1. So this product rule corresponds to this right here. Everything else we had done. E to the minus xy times 1 is just e to the minus xy, 2y, y prime. Now whenever possible, we want to solve explicitly for y prime. It's going to be possible in this one because we can get the terms with y prime on the same side, but first we're going to need to get rid of these parentheses. So let's distribute that term here. So right here, we're going to have an x times an x, so we're going to have negative x squared e to the minus xy, y prime. And when we do this term, I'm going to put the negative out front, xy e to the negative xy, plus e to the negative xy equals 2y, y prime. Now, let's go ahead and solve this for y prime. Or excuse me, before we do that, we need to get this term over to the other side. So we're going to add x squared e to the minus xy, y prime to both sides. So plus x squared e to the minus xy, y prime. That'll cancel it out over here, and that gives us both terms with the y prime in it. So we have minus xy e to the negative xy plus e to the negative xy on the left-hand side equals y prime times, we factor out the y prime here, we'll have left 2y plus x squared e to the minus xy. So now we can solve explicitly for y prime, which is negative xy e to the negative xy plus e to the negative xy over 2y plus x squared e to the negative xy. Nice long one, right? Okay, now what we need is we were finding the we were going to calculate this at 0.571433, 1. So we need to plug that in for our x's and y's into our derivative to get the slope. So m equals y prime at the point 0.571433, comma 1. So this can be a little tedious to put into a calculator. What I want to show you is one way that maybe you like it, maybe you don't. So let's see how we can leverage our calculator to put this thing in. So what I'll do is we'll leave there, and I am going to use one of my letters, perhaps A, and I'm going to store that 0.571433 so I don't have to type it every time. And I have that backwards. My apologies. Store that for A. Because now anytime I bring up A, it's going to have that number in there, so I don't have to keep typing it. Now what I'm going to do is I'm going to plug A in for x and 1 in for y into this equation here in my calculator. So I see that I have a negative A times y, which is 1. So I'll just put it all in here so you can see it, times second e raised to the, it's going to be negative A times 1. And we'll get out of the exponent plus second e to the negative alpha A times 1, and that completes our numerator, divided by now our denominator. Again, I'm going to have to put that in parentheses, 2 times 1 plus, that's going to be my A squared times e being raised to the negative A times 1. And we'll get out of there, we'll close our denominator, and there is our slope. So we get that m is approximately 0.11079. We now have enough information to find our the equation of our tangent line. Y equals 0.11079 times x minus 0.571433 plus 1. So there's how we can find the tangent line to that function at that point.